Good morning, everyone. I hope you're enjoying the panels so far today. I am Jacquelyn Melinek, as the screen says, and I am here with our panelists. Next to me, I have Dan Simerman. He's a principal advisor at Mintify. And then next to him, I have Dave Schwed, the chief operating officer at Halborn, and then Scott Stornetta, partner and chief scientist at Yugen Partners, and then Shaul Kfir, co-founder and COO of Digital Asset. And I think to start, I kind of want to get a sentiment vibe check from you guys. What have the conversations with traditional institutions been like, and what is the sentiment towards digital assets right now? What are you hearing?
I think when we look at digital assets, we really need to separate into two. There's cryptocurrencies, and then there is what I'll call the institutional digital assets. So that's digitizing assets in the real world on blockchain technology. On the former, we're definitely seeing, first of all, I'll give some background. Digital asset, we are on the latter side, on the institutional blockchain side. But we're definitely seeing across our customers, I think there's more reluctance right now to go into the crypto space, and there's a lot of concerns both on the regulatory and on the security side. So we're definitely seeing a lull, and I think that goes with the crypto price booms and busts. On the institutional blockchain side, we're definitely seeing a very large increase over the last year or two in appetite and willingness to go and tokenize both assets and workflows on blockchains. And that's across things like tokenization that can be US treasuries and bonds and mortgages. We're seeing that really across every industry. But also things that may be a bit more obscure, like things like managing workflows on a blockchain, on institutional blockchain. So we're seeing things around sports betting, around insurance, supply chain management. But there's definitely an increase. There's definitely what I'll call a kind of flight to quality of realizing that there are some platforms that are more suitable for enterprise use cases than others, and we're seeing more and more things coming into production. I was just talking with Dave backstage. There are a lot of companies like Broadridge that people aren't aware, but they are doing more than $100 billion a day of repo trades on a blockchain. And that's great. When things start becoming boring and you don't hear about them because you can't get rich off of a token, that's great. It means things are really progressing. So there's a lot of appetite right now, and I expect in the next year we're going to see a huge amount of new tokenization coming online on blockchains.
Thank you, Shaul. I'd say there's a kind of a two-way bifurcation that I'd also make between internal infrastructure and process, which is such a touchstone. When it starts to involve process and reworking workflows, then you know it's getting embedded. And our investment thesis shies quite a bit away from cryptocurrencies and is more about what commonly called picks and shovels. But when you integrate those workflows, you're sort of married for life, and that's a good thing if you have a recurring revenue stream. When it comes to the cryptocurrencies, sort of the Wild West side of things, there's kind of a love-hate relationship is what I see. It reminds me a little bit of the One Ring. You know you want it, but it's a little dangerous. And I guess the way I'd phrase that a little less theatrically is I was in a meeting with the board of directors of one of the nation's large banks. And they knew that eventually they needed to find a way to give their customers access because their customers were leading them. And yet the appropriate and entrenched instincts of risk avoidance for conventional banks made them think twice about putting the ring on. So, yeah, that's how it's.
Yeah, for me, I think I'd kind of boil it down to confusion and somewhat reluctance and FOMO. There's this, as brought up by them, there's this confusion around cryptocurrency, digital asset versus digital ledger technology. And I think everyone agrees that this is an amazing technology, and a lot of the large banks and enterprises are trying to find use cases for the technology. And obviously there has to come revenue with that. And I think that's really what's setting a lot of the enterprises back is this is amazing technology, everybody's asking for it, but we can't make money in it. And I think that's where a lot of the apprehension and a lot of the reluctance to really fund a lot of these amazing projects is because you have to, well, how are we going to make money off of this? Or, what is the use case? What's the ROI? And I think we have to stop looking at this as where is the money going to come from? And I think you have to look at it in twofold. One is digital ledger technology is a replacement for existing technologies is one. And two, if you don't get on cryptocurrency to the digital asset train, it's not about finding new revenue, it's about you're going to end up losing revenue because this is going to be a paradigm shift in financial services, and it's about maintaining your revenue and not necessarily finding new revenue. We're not inventing capital. Well, I mean, you can print money, but you're not necessarily going to create new revenue in markets that didn't exist before, but you're going to start to see a shift from traditional financial service products into digital asset products, and it's about being there and having the infrastructure ready in order to capture that market.
Yeah, and I'd also just say, I think that the infrastructure is shifting so quickly that there are some things coming down the pike that are going to fundamentally change how many enterprises and institutions think about digital assets and public networks. My understanding is that it's really been a question of, do we use a permissioned network or do we put our data on chain? And I worked for a very large layer one for years, and the premise was, we were building a different type of architecture. It was like a variation of a blockchain called a DAG. And the thought was, okay, that's going to be the thing that brings enterprises in because you could create a distinction between database transactions and value-based transactions. But we quickly found that most institutions they don't want to put their data on chain, and they want to really be able to control them. Some of the questions we have later, will touch upon some of these newer technologies that I would recommend, like everyone in this room, have their research team start looking into if they're not already, because I think that there's going to be a kind of revolution where you can interact with, you can bring, using like off-chain computation, you can interact with public networks, and it's going to create a lot more interoperability and composability so that you can interface with these large global public networks, but still have that layer of privacy and trust and compliance.
I feel like we're kind of at like the edge of adoption between enterprise and institutions getting into this space. And obviously this panel is called Security and Privacy Considerations. So I've got to ask you guys, what problems still persist there on that front that is impeding the growth for both institutions and enterprise companies getting into this space?
The biggest problem is one word, and that's humans. The blockchain environment, what people like about it, its atomic nature and the immutable append only, is also very unforgiving. And to me, again, even when speaking with sophisticated people involved in this space, I remind them of the 3 rules. Rule number 1, don't forget your key. Rule number 2, don't give someone else your key. And rule number 3, remember rules 1 and 2. It's really the human element at the core of it that is still the problem. But I guess I would just add one other thing, and that is, Stuart and I did that original pre-Satoshi blockchain work, and it wasn't really a true blockchain at that point. We call it a proto-blockchain. But there's one intrinsic aspect of blockchain or DLT or whatever you want to talk about that should give people solace at night. And that is this decentralization of trust meant that there were no longer a paradigm of insiders and outsiders in a conventional sense, trying to prevent outsiders from breaking in and compromising insiders. With the blockchain, at its fundamental level, I'm not talking about smart contracts, for example, but at its fundamental level, there are no insiders. And the more that people can align themselves as they build, layer after layer on top of the layer 1 protocols, that they can align themselves with that intrinsic strength, the more long-lasting their solutions are going to be.
And I would just add to that I think sometimes people overthink, like, what is blockchain needed or used for? And I think to your point, like, just censorship resistance, right? In a world where infrastructure is becoming so polarized, where you don't know the third party that might be controlling it, and if they don't like your institution or your organization, whatever, they could censor it, right? So just in a world where you can have permissionless value transfer, that is a huge use case in this up and coming world, and I think oftentimes it's overlooked as like, is that really a reason?
It has a lot of sharp edges, but at its core, there's some real strengths that people should reflect on.
On the institutional side, I think the biggest problems that we're seeing today is, one, almost all of the blockchains out there don't solve together for all of the properties that we come to expect of blockchains: consistency, immutability, together with privacy. The trade-off is usually too hard. You get one or the other, and all of the attempts to do layer 2s or roll-ups or things on top of blockchains or private channels, they break the abstraction in a way that then they push all of the complexity to the developers. And I think a lot of the security problems that we're seeing in protocols are because developers don't understand the nuances of that complexity when you're pushing that complexity. I am talking a bit of my own book here, so apologies for that, because Digital Asset did come out with a blockchain called Canton together with another 30 institutions. But I do think we're going to see a new type of blockchain, whether it's Canton or others, which are open networks, but open permission networks. So every part of the network, every application has its own sovereignty, its own permissioning. But still, we have that privacy, but we still have the open network, the open network properties that we come to expect. And we really need to get to more of those abstraction levels where the end developer doesn't have to think about security, and that every institution can decide what are the security properties, what are the permissions that they allow. We give the analogy a lot of times of the internet. On the internet, is it a public network? Is it a private network? It's an open network. It is permissionless to go and do something on the internet, but every portion of the internet is permissioned. If I go to chase.com and I'm not a Chase customer, I can't log in. And if I am a Chase customer, I can only see my data. I can't see other people's data. And we need to see the same kind of shift in blockchains, and we are starting to see that, where every application provider can decide, has sovereignty over their application, including things like throughput. I shouldn't be beholden to a network's throughput. I need a design that allows me to add my own servers and add my own infrastructure as I need it, and to bring down my application, to upgrade my application, of course, sometimes in coordination with my customers. But to upgrade my application, I need to coordinate with my customers, not with the whole network.
So I have a statement and a question. So Dan, you brought up censorship resistance as one of the core, I guess, ethos of this technology. Can we really achieve that with the fact that this infrastructure still has centralization in it, in the sense of you still need telecommunications, you still need servers, you still need the network stack? Like, there's still components of this infrastructure that have centralized components of it. And if we look at what the federal government was doing with a threat of sanctioning U.S. companies that were hosting validators that were going to be validating blocks that had transactions that were coming out of a tumbler, to me that's a threat of that we can never fully get actually censorship resistance. So I'm just curious, like, what your thoughts are on that.
I think it's kind of where it is on the stack, right? If like the layer 1 and the validators, if they're decentralized enough, if I can send a transaction, if there's a service provider that's trying to censor it, there's going to be another that's where it's available. I think the difference is there's going to be some systems where there's going to be a third party that can just press a button and say, "Oh, I'm just going to freeze your account." Right? I'm not going to let you send that transaction, and I don't think that's what we want. And I'm here representing a group called Mintify, and they're really focused on like NFTs. I know a lot of times in enterprise, NFTs are kind of overlooked, but if you think about the NFT economy thesis, which is that gaming and music and the tokenization of real-world assets, like all of these sub-economies will probably leverage the ERC 721 standard or something in that vein. Like, again, these are all assets that like you don't want. When we move into a world where social networks have value on chain, right? Everything kind of becomes liquidity on chain to some point. If you've got $500,000 in a social account, you don't want someone to freeze that, right? So my take is that if the base layer, if you can always send a transaction, that to me is like the most important. I think if there's parts of the infrastructure stack that are centralized or owned by third parties, like I generally think that's fine. I think that's just part of building an ecosystem.
But if I may, I would like to challenge the premise that censorship resistance is a kind of something that we need in blockchains. I think there are certain applications, Bitcoin definitely, the design, the feature that Satoshi wanted there, one of the features was censorship resistance. So for some applications, censorship resistance is important. But I really think the two kind of exciting features, again, more enterprise definitely than cryptocurrency enthusiasts, but one is DeFi. It's the ability to do atomic transactions across multiple different applications. And I think if we look at the SaaS era and the cloud era, that brought us the amazing feature of being able to get the aggregate of many APIs pulled from many different companies, but we don't have that ability to put in a transaction, to do something atomically across multiple applications. And I think DeFi is a huge feature of, I'll call it the non-Bitcoin, all the blockchains that came after that. Another one is just the data replication in real time. So the ability to know that I have a faithful real-time replica of data that is my system of record that can't be falsified. So once it's been updated, I'm the one in control of that data. And if it changes, I may not have control of every change, but if it changes, I see why it changed. I think those are really the two killer features of blockchains. And putting aside Bitcoin, Zcash, the cryptocurrencies that are there to be censorship resistant. But if Clearstream is now settling bonds in Germany on a blockchain, which they are, they should be able to censor a bond transfer.
I would just say there's a difference between putting permissions at the application layer and having a third party controlling it at the layer one blockchain layer. That's a different conversation.
Yep.
Yeah, again, I think you're scoring on both fronts these points. You have to think about the blockchain as a very large design space. And Satoshi made a very unusual decision about where in the design space he wanted to allocate resources. He put an enormous premium by creating a proof of work model into this censorship resistant. This is the old internet. The internet treats censorship as simply an error to route around, okay? So as long as you've got that other option, okay? But there's plenty of economies of scale and just efficiencies that can be taken advantage of if you don't feel that that's the issue that you have to put so much of your effort into. And that's really what the enterprise is about. When you can have a certain level of confidence that there's incentive to continue the operation of the thing, you can take a lot of the energy that Satoshi, put into going out in a far right field and use it for other purposes.
Yeah, that's something that I feel that a lot of the attempt to apply, like we're spending so much effort on looking at the security of layer ones that aren't necessarily appropriate for the things for the trust model of an enterprise. And I would really like to see more of the security focused on other parts and not on the proof of work and proof of stake of layer ones.
What other parts are you considering in that, and how does that kind of play of effect in the adoption? Like, do you think these companies are kind of ready for everything that you guys are talking about, or is it kind of out of their wheelhouse?
When you need to choose a platform that makes sense for your security model, but I'd say the one is the abstraction level of the blockchain. So making sure that we need to assume that developers will make mistakes. And we need to make sure that those mistakes are not catastrophic. So that's the first area that I would like to see companies look much more. And the second part is we look a lot at prevention. I think we need to look much more at remediation. If we look at just the state of cybersecurity, regardless of blockchains, it's horrific. We have supply chain attacks. No one is secure completely. So we need to assume that kind of like military thinking. Things will go wrong. So the question is, how fast do we recover? How fast do we get back to normal operations once things go wrong? And that has to be baked into the platforms, that has to be baked into the applications. I would really love to see more and more focus on that from.
But I feel like there has to be a focus on not having these things happen, attacks, exploits, because institutions don't want that to happen and then be like, oops, we should have caught it next time. Like, it should be preventative, not action after the fact. And of course, we can't prevent everything, but
It must be both. It must be both. That's my.
Well, of course, yeah.
Yeah, I actually want to push back a little bit on that, because in the real world, things break, and that's why you have redundancy. That's why you have fallback scenarios. And, we're coming from an environment where this happens all the time. I'm talking about the traditional finance. And they just have, fail-safe mechanisms, fallback mechanisms. And so it's a lot better to treat the system as a fallible system, and then you just keep trying to ride down the failure curve to smaller and smaller amounts of, failure, higher and higher amounts of uptime, than to imagine that this ideal is realized from the start and therefore it's perfect, so we don't need any fallback mechanisms. That's a very brittle system.
So I'll say quickly, so y'all probably hear this all the time, there's the new technology that's going to change everything. But there was a mathematical breakthrough in like the 70s that's found real life applications in the last couple of years in distributed ledger technology called zero knowledge proofs. And what's fascinating about zero knowledge is that you can create, it's called like provable computing. So you can verify computation and then post it onto public networks. And I think that's going to be a big shift into how enterprises think now. I think in the past it was, how do we create a permission network so that we can kind of, create a trust network between parties? Now it's going to be, okay, can I run, a private blockchain or a set of computation off chain, so in my own enterprise environment, and then post that to public networks. And what's very cool about that is that there's some inherent security and privacy characteristics embedded in those. So I'd highly recommend digging into those, because I think that it could be the thing that actually bridges the gap. And this is, again, coming from someone that worked with a very big blockchain and like launched big public networks, where I thought that was, it was really going to come from like the consensus layer or the design of these like older layer ones. But I actually think that zero knowledge and what they're calling like ZK or succinct blockchains, it's going to completely upend a lot of notions that we have about like infrastructure and what is a layer one and what's a layer two, and how do even servers interact. So many groups right now are trying to like zero knowledge Web3, but there are some groups. So there's a group that I'm advising called Lurk. I would highly recommend checking it out. Where they're creating zero knowledge domain specific languages where you can rebuild a lot of parts of the technical stack in these like zero knowledge ways. It's a way larger conversation, but I would say that that's probably the thing that's going to bring real life security and privacy to not just, again, the digital asset side, but also like real data interacting with public networks.
Well, I agree with you on the real data, but the reality is, again, we're still in a world, a capitalistic world, where people want to make money, and when these technology is tied to assets that are bare assets and the transactions are immutable, and to your point about failure, yeah, from a tech stack, from a uptime and from a stability perspective, yes, I agree with you. But when there's a failure in the code or a vulnerability and it leads to a loss of actual money and it's putting companies out of business, that's where I think like it's still a challenge that I think or a problem that we haven't fixed or solved.
I was one of the co-authors of LibSnark, which is the first popular zero-knowledge proof library in domain-specific language. So actually, when we started the company, I thought we would be using that quite a lot. But I find myself disillusioned with zero-knowledge proofs. I think it's an amazing technology. It works very well for very narrow use cases. But what I'm seeing is that people are looking at it as a panacea today, which it isn't. And I'd say there are many problems, but I'd say there are two main ones that I see. One is zero-knowledge proofs, as they're being used today, are mostly being used for to solve scalability issues. And they work very well there. They don't solve the privacy issues because the programming models don't have privacy baked in. So
you have to design them.
Right. You have to design, and all of the current designs of all of the current languages are just way too low level for a mere mortal developer to deal with them. The second thing is, and if we go and assume there will be software bugs, and every zero-knowledge proof system that went into production that I'm aware of had bugs in the wild that were integrity bugs. So every one of those, I'll give the example of Zcash, and I love Zcash. Many of my friends are founders of Zcash, and I own some myself. But there was an integrity bug in Zcash way back, and we have absolutely no way of knowing if someone exploited that and if they've minted 1 trillion Zcash for themselves, and we will never know. And by design, because it's so strong theoretically that we know that we can't ever find that out, so we now know we have an integrity bug in Zcash. I don't believe it was exploited. I don't know. But the thing is that that's not the type of concern that most enterprises can live with. They need to be able to remediate if something went wrong. If there was a zero-day bug, they need to be able to know, was it exploited? So that's one of the problems. Again, I love the technology, and I believe it will find very important narrow use cases. But I think we're very far away still from having generalized use cases for zero-knowledge proofs at this point.
I would just say I think these upcoming languages are more for like general. They're not just security. They're not just privacy. You can build out entire circuit models, and it's not like Zcash, where I think you could argue it was like hard coded, right? You have like front ends and back ends that are more modular, and I think it does allow for like better testing for things like this. But
All right, awesome. Unfortunately, we have to wrap it up there, but thank you to our panelists for sharing their insights, and thank you to everyone else for listening in.